right, so the last question for this lesson is, how could Janelle get an even more accurate estimation of the probability? Now, the way that I look at this is that it is in this way. Way back here on A, we were able to get all 3 toys. So because of this, if we had stopped right there, that means Janelle got all 3 toys 100% of the time. 1 out of 1. She was guaranteed to get all 3 toys. Is that true? Is that accurate? Is being guaranteed all 3 toys accurate, or is this percentage more accurate? Hopefully you realize that this percent right here is not as accurate, or is more accurate than the first one, because some kids didn't get it the first time in class on A, so they were guaranteed to never get all 3, right? And so again, we know that realistically with this percentage here is more probable, right? So it's more accurate. What can she do though to make it even more accurate? And this is hard for me to point out because normally if you were in class, I would be able to say, hey, this student right here, their percentage of getting the toys was 25%. But sitting right next to him might be somebody who has a percentage of getting all 3 toys 80% of the time, right? That's a big difference between 20% and 80%. So what we could do to make it even more accurate is that Janelle can run the simulation even more. She might run it 50 times or 100 times, and it's going to continue to get more and more accurate the more that she runs that simulation. So she can run simulation more times for her to be even more accurate. So she could run it 50 times, so 30 more times to 50. She could run it 100 times. I wouldn't want to run it 100 times. But remember, in that example they also talked about before, in the real life ones, that they run a simulation like this tens of billions of times, right? Computers can run for days crunching those numbers to see what is accurate. Okay. So again, we're running that computer simulation to see what's the probability that an event will